Hello students. So in this class let us discuss exercise 3.3 of this chapter trigonometry. We will start. First question, prove that question number 1, sin square pi by 6 plus cos square pi by 3 minus tan square pi by 4. The simplified value should be equal to minus 1 by 2. Proof. And sin square pi by 6 plus cos square pi by 3 minus and tan square pi by 4. Sin pi by 6 is 1 by 2. So 1 by 2 the whole square, 1 by 4. Cos pi by 3 is root 1 by 2. 1 by 2 the whole square, 1 by 4. And tan pi by 4, 1. So 1 square, 1. 1 by 4 plus 1 by 4, 1 by 2 minus 1 is minus 1 by 2. Okay, and copy this. We'll go to next question. Second question, prove that 2 sin square pi by 6 2 sin square pi by 6 plus cosecant square 7 pi by 6 into cos square pi by 3. The value should be equal to 3 by 2. Okay, proof. And 2 sin square and pi by 6 plus cosecant square 7 pi by 6 pi plus pi by 6 into cos square pi by 3 and 2 sin square pi by 6 and cosecant of 180 plus theta cosecant minus cosecant theta, because more than 180 third quadrant, the third quadrant cosecant negative, but cosecant square no positive. So cosecant square pi by 6 cosecant square pi by 6 cosecant square pi by 6, okay, into cos square pi by 3. Now all the angles, now basic angle and acute angle in the first quadrant, and 2 sin pi by 6 1 by 2 the whole square cosecant pi by 6 2 and 2 the whole square cos square pi by 3 1 by 2 the whole square. So 2 into 1 by 4 1 by 2 plus 2 square and 1 by 2 square 1 overall 3 by 2. So this is the required answer, 3 by 2, and copy it. We'll go to next question. Third question, prove that cot square pi by 6 Okay, plus cosecant 5 pi by 6 plus 3 tan square pi by 6 should be equal to 6. Okay, proof. And cot square pi by 6 plus cosecant 5 pi by 6 is pi minus pi by 6 plus 3 and tan square pi by 6 and cot square pi by 6 cosecant of 180 minus theta. This angle falls in second quadrant. In the second quadrant, cosecant positive. Allied angle multiply by mean cosecant goes to cosecant plus cosecant and pi by 6 and plus 3 and tan square pi by 6 and cot pi by 6 root of 3 square 3 cosecant pi by 6 2 plus 3 and tan square pi by 6 1 by 3 and 5 plus 1 is equal to 6. Okay, so this is the final and required answer and copy it. Then we will discuss question number 4. Just copy it. Question number 4. Question number 4. Prove that two sine square 3 pi by 4. 2 sine square 3 pi by 4 plus 2 cos square pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3 plus 2 secant square pi by 3. The simplified value should be 10. So let us try to get the answer. Proof 2 sine square and 3 pi by 4 can be written. Okay, 3 pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3. Then 2 sine square pi minus pi by 4, correct? Plus 2 cos square pi by 4 plus 2 secant square pi by 3. Okay. Then sine of 180 minus theta. Second quadrant, allied angle pi, so sine only. Sine square pi by 4. 2 sine square pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3. Taking 2 common, sine square pi by 4 plus cos square pi by 4. Identity. Sine square theta plus cos square theta is 1. So we can combine these two. This is 2 plus 2 secant pi by 3 and 2 square. 4 into 2 8, 8 plus 2 10. So this is the required answer. Copy it. Dear student, question number 5 and 6 we had already discussed during the discussion of example problem in the previous session. And for your reference, I write the questions, then you can remember. What is question number 6? Not 6, question number 5. Evaluate sine 75. Sine 75. How to write? Sine of 45 degree plus 30. Let's expand it. Okay, we had already done. And question number 6, tan 15. And that also we have done already. What is the answer? 2 minus root 3. You can practice once again. Self practice. Okay. Now we'll go to next question number 6. Sixth question. 5, 6. This is 5. This is subdivision 1 and subdivision 2. From the book, this is subdivision 1, subdivision 2. So we had already done this question. Question number 6. And prove the following. Prove that cos of pi by 4 minus x into cos of pi by 4 minus y minus sin of pi by 4 minus x into sin of pi by 4 minus y should be equal to sin of x plus y. Okay, and proof. Let us take angle A is pi by 4 minus x, angle B is pi by 4 minus y. Then LHS and cos pi by 4 minus x and cos pi by 4 minus y minus sin pi by 4 minus x and sin pi by 4 minus y. Sin A, cos A, that is cos A, cos B minus sin A, sin B. Which formula? And cos of A plus B. Cos of A, that is pi by 4 minus x and B pi by 4 minus y. Then cos of pi by 4 plus pi by 4 pi by 2 minus of x plus y and cos of 90 minus theta sin theta. What is theta? The compound angle x plus y, hence the proof. So this is the required result. We have got it and go through it. Understood? Question number 7. And prove that tan of and pi by 4 plus x divided by tan of pi by 4 minus x is 1 plus tan x by 1 minus tan x the whole square. And proof. Dear student, tan of pi by 4 plus x using compound angle formula of tan of A plus B, tan A plus tan B in the numerator, denominator 1 minus tan A into tan B, that is tan pi by 4 plus and tan x, the denominator 1 minus tan pi by 4 into tan x, this is 1 plus tan x by 1 minus tan x, because tan pi by 4 is equal to 1. And similarly, tan of pi by 4 minus x, 1 minus tan x by 1 plus tan x. Now we can use the result tan of and pi by 4 plus x and tan of pi by 4 minus x. For the numerator, 1 plus tan x by 1 minus and tan x, division 1 minus tan x by 1 plus tan x. On simplification is 1 plus and tan x by 1 minus tan x the whole square. Okay, this is the final result. And see proof and go through it. We'll go to next question. Question number 8. Question number 8. Prove that what the question? Cos of pi plus x into cos of minus x. Cos of minus x. The denominator, sin of pi minus x. There is one more factor, cos of pi by 2 plus x. And we have to show that the simplified value cot square x. Let us start our proof. Then cos of pi plus x, cos of minus x, sin of pi minus x into cos of pi by 2 plus x. And follow me. Cos of 180 plus theta falls in third quadrant. The third quadrant cos negative. Allied angle pi mean cos goes to cos, and third quadrant. So first one is minus cos x. And cos of any negative angle, because minus x falls in fourth quadrant. In the fourth quadrant cos is positive, and cos of minus x cos x. Pi minus x, second quadrant. In the second quadrant, sin positive, allied angle pi, sin goes to sin, is sin x. And cos of 90 plus x, second quadrant, the second quadrant cos negative, allied angle pi by 2 mean cos goes to is co-ratio, sin, minus sin x. Negative and negative positive, cos square by sin square, and cot square x. Hence proved, and copy it. We'll go to next question. That is question number 9. Question number 9. And prove that or show that cos of 3 pi by 2 plus x into cos of 2 pi plus x into cot of 3 pi by 2 minus x plus cot of 2 pi plus x. And we have to show that this result is 1. Okay, and proof. And let us take cos of 3 pi by 2 plus x into cos of 2 pi plus x into cot 3 pi by 2 minus x into cot 2 pi plus x is equal to 3 pi by 2 odd multiple of 90 is allied angle limit, cos goes to sin, and more than 270 falls in fourth quadrant. In the fourth quadrant cos is positive, so this is sin x. Cos of 3 pi by 2 plus x is sin x. And cos of 2 pi x, cos is a periodic function of period 2 pi, rotational angle, one rotation, cos of 2 pi plus x cos x. And 3 pi by 2 minus x mean at less than 270, third quadrant, the third quadrant cot positive, and because of allied angle odd multiple of 90, cot goes to co-ratio of cot, that is tan x. And cot 2 pi plus x is a multiple of period and cot x. So sin x and cos x, this is sin x by cos x, the other one cos x by sin x. So sin x into cos x, this is sin square x plus cos square x by sin x into cos x, correct? This and this cancel. The remaining part is identity. Sin square x plus cos square x is 1. So 1. Hence the proof. Let's copy it. We'll go to next question. And so far we have completed 9 questions from the exercise and 3.3. In this particular exercise, the total number of questions and 25 questions. So we need one more session to complete the exercise 3.3. Now we'll continue question number 10. Tenth question, prove that sine of n plus 1 in dx and sine of n plus 2 in dx minus, that is sin plus cos of n plus 1 in dx and cos of n plus 2 in dx. Okay, we have to show that this cos x. We have to show that cos x. Okay, sine of n plus 1x, sine of n plus 2x, and cos of n plus 1x, cos of n plus 2x. Proof. Let us take angle A is n plus 2 in dx and B and n plus 1 in dx. Then, and cos of n plus 2 in dx in the cos of n plus 1 in dx and plus sine of n plus 2 in dx and the sine of n plus 1 in dx is equal to cos of A minus B. A is and n plus 2 x, then n minus 1, minus n minus 1 in dx. N and n cancel, 2 minus 1, 1 in dx cos x. Okay, hence the proof. And copy it. This n plus 2 in dx A, n plus 1 dx B. This is nothing but A minus B. Cos of A minus B, cos A cos B plus sin A sin B. And go through it. We'll go to one more question. Question number 11. Prove that cos of 3 pi by 4 plus x and minus cos of 3 pi by 4 minus x should be equal to minus root of 2 sin x. Minus root of 2 sin x. Dear student, let us take and this is a plus b, the other one a minus b. It is known that cos of a plus b minus of cos of a minus b is equal to minus 2 times sin a into sin b. And here a equal to 3 pi by 4 and b equal to x. Then cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x equal to minus 2 sin a is 3 pi by 4 and sin b is x. Minus 2 sin this pi minus pi by 4 into sin x minus 2 and pi minus pi by 4 second quadrant. The second quadrant a positive, so allied angle pi, this is sin pi by 4 into sin x. So minus 2 into 1 by root of 2 into sin x. On simplification, minus root of 2 and sin x. So this is the expected answer. And see proof. We'll do one more question and copy it. And question number 12. We'll discuss question number 12. With the question number 12, we'll wind up this section. Then we will continue from question number 13. Just copy it. And question number 12. And prove that sin square 6x minus sin square 4x is sin 2x into sin 10x. So dear student, you have to remember it is known that one familiar identity sin square a minus sin square b is equal to sin of a plus b into sin of a minus b. If we replace sin square a is 1 minus cos square a, this 1 minus cos square b, the same thing, and cos square b minus cos square a also sin of a plus b into sin of a minus b. And remember these two identity. Using this identity straight away, sin square 6x minus sin square 4x. Sin square 6x minus sin square 4x is equal to sin of a plus b 6 plus 4 10x into sin a minus b 6 minus 4 2x. So therefore sin 2x into sin 10x. So dear student, and see proof. So with this question number 12, let us wind up today's session. And still we have to discuss now 13 more questions from the exercise 3.3. So let us meet in the next session.